back to another Daishinfinity video. In this video, we're going to talk about the derivative of this trigonometric function cosecant of x. So in this video, we're going to try and prove that the derivative of cosecant of x is equal to the negative of cosecant of x times cotangent of x. Now, before we dive right in, we have to think about what a derivative actually means for us. The derivative of any function f of x is given by the limit definition. So we have the limit as h approaches 0 of f of x plus h minus f of x all over h. Now that is our whole formula, and now we're going to try to plug in the cotangent of x for the f of x inside. So we'll just get the derivative of not cotangent, cosecant of x. So the derivative of cosecant of x is equal to the limit as h approaches 0 of cosecant, cosecant x plus h minus cosecant x all over h. Now what is cosecant? Cosecant is just the same thing as saying it's the derivative of 1 over sine x. So we're just going to plug in the sine x into our limit so that we can deal with sines and not cosecants, which will make it easier for us to apply it here. So we'll just have 1 over sine of x plus h minus 1 over sine x all over h. Now what we are going to do is we're just going to cross multiply so that we can put those fractions together. So we just have limit as x approaches 0 of sine x minus sine x plus h. Now we're just going to put the h in the denominator too, so we'll just have h times sine x plus h times sine of x. Now this is what we have. Now what we're going to try and do is we are just going to see what we can find here. Sine x minus sine x plus h. What kind of property do we have here? Now if you look at this property, we can just rewrite it as the negative of sine of x plus h minus sine of x. And this reminds us of our trigonometric identity. Let me make it smaller so that we can see what's going on over here. So this is just sine of a plus b minus a. Minus sine of a. And from an identity, we know that this is just equal to 2 times the sine of b over 2 times the sine, times the cosine of a plus b over 2. So since we have this, we can apply it over here into our property. So we have negative sine x plus h minus sine, which would just equal to the negative of 2 times the sine of b over 2, so h over 2, times cosine of a plus b over 2. So this is our property, and just multiplying the minus with the negative with the 2, we will just have negative 2 sine h over 2 cosine x plus h over 2. Now this is what we are having. So from this point we can go onwards and just plug this whole thing into our limit. So this will equal to our limit as h approaches 0. We always have to write the h approaching 0 of negative 2 sine h over 2 times cosine x plus h over 2, and the whole thing over h times sine of h plus x plus h, I don't really care, times sine of x. Now what we can do is we can take a look at sine of h over 2 over h. Now we know one limit, that the limit of any variable going to 0 of sine of the variable over the variable itself is just equal to 1. Now over here we have h over 2, so we have to make this h over 2, multiply this by 2. This 2 and this 2 will cancel, so this will leave us with the limit. Since we use the limit property that a limit of a times a limit of b is the same thing as the limit of a times b, we're just going to take the negative sine h over 2 over h over 2 and times the limit, so we're just going to divide it into two limits. So we have the limit as h approaches 0 of cosine of x plus h over 2 and the whole thing over sine of x. Now what we're going to do, we know that this and this, when we let it equal to t, let's say h over 2 is equal to t. Now when h approaches 0, t also approaches 0, so nothing will change. So this will approach -1 since we have the negative in front. So if we rewrite it, then we would have the negative of the limit as h approaches 0 of the cosine of x plus h over 2 over the sine of x, I think so, yes. So sine of x. So this is what we have. And I forgot to put the sine of x plus h into our limit. So this is still sine of x plus h. So this is still in our limit over here. So we'll have sine of x plus h. Let's rewrite it clearly so that we'll have a nice limit. So our limit as h approaches 0 of cosine of x plus h over 2 and the whole thing over sine of x times sine of x plus h. Now let's let h approach 0. Then we can see that this approaches 0 and this approaches 0. So we are just left with the negative of cosine of x all divided by sine of x times sine of x. So when we write it down like this, it will be 1 over sine x times cosine x over sine x. And that will leave us with negative cosecant x, cotangent x. So right now we have just proven that the derivative of cosecant of x is equal to negative cosecant of x times cotangent of x. So I hope you like this video. Please like and subscribe if you want to see more videos like this, and we'll see us in the next Daishinfinity video. See ya.